everyone and welcome to e-sipnayan. So for today's video, I'm going to be discussing an introduction to conics. But of course, before anything else, please don't forget to like and subscribe to e-sipnayan to be updated with more of our videos. Now let us start with the question, why do you think it is called the conic section? Now of course, based from the word conic, a conic section is a curve formed by a plane passing through a double-napped circular cone. So a double-napped circular cone is formed when two cones are connected by their vertices. Now, if a plane passes through these circular cones, different conic sections may be formed based on the angle or how the plane cut the following circular cones. And now we have four kinds of conic sections. As you can see, we have the parabola, the circle, ellipse, and hyperbola. And now basing from the illustration that we are seeing right now, different cuts of the plane through the circular cone can be used to get these conic sections. Now we can differentiate this conic section by the cut of the cones or by their general form as well. Now differentiating the conic section by their cuts, now a circle is made when the plane cuts one of the circular cones perpendicular to its vertical axis and parallel to its base. So we can imagine that here we have the vertical axis. Now if the vertical axis is perpendicular or it creates a 90-degree angle with the plane and it is parallel to the base of the cone, then we can assume that the intersection is a circle. Now, if we are to create a parabola, the plane should be parallel to one side of the cone and intersects one of the two cones. So take note that this plane should only intersect one of the cones and it is parallel to one side of the cone. So if we have this side of the cone, that it is parallel or they have the same angle as the plane. Now with this kind of angle of the plane, we can make a parabola. So for an ellipse is formed when the cutting plane is parallel to one side of the cone, but in a certain angle, it intersects only one of the two cones. An ellipse is very similar to a circle. A circle can be formed when it is exactly perpendicular to the vertical axis. But for an ellipse, it shouldn't be perpendicular and it should have a certain angle. Any angle as long as it is not perpendicular. As for the hyperbola, the only conic section that intersects both of the cones is a hyperbola. It is formed when the cutting plane intersects two of the cones parallel to their vertical axes and perpendicular to their bases. Now, as I've told you earlier, this is the vertical axis. Now, if the plane cuts the double-napped cone parallel to the plane and perpendicular or forms a 90-degree angle with the base of the cones, then we can assume that it forms a hyperbola. So this is how we differentiate conic sections based on the cuts of the planes. Now let's try to determine the conic section represented by the following graphs. Now for the first graph, since it is curved, we can definitely assume based from the four options of circle, parabola, ellipse, and hyperbola that this graph is a parabola. Now for the next graph, it is perfectly circular, therefore this conic section is a circle. Now, if the graph has two curves, we can only assume that this is a hyperbola. And finally, we can see here one curve. We can say that this is a parabola that is opening to the right. As for this graph, we can say that this is an ellipse. And finally, in this graph, of course, this is a hyperbola. Now, another way of differentiating conic section is by their general form. Now, this is the general form of all of the conic sections. So please take note that their general form is a polynomial with only two variables, x and y, and the degree of this polynomial is 2, meaning the exponent or the highest exponent in this equation is 2. Now, if a is equal to c or a and c have the same coefficient, then we can assume that the conic section is a circle. But if either A or C is 0, then we can assume that it is a parabola. As for the ellipse, if the product of A and C is greater than 0, but A is not equal to C, then it is an ellipse. But for a hyperbola, if the product is less than 0, then it is a hyperbola. Now let's try identifying conic sections given the general form. Now we have list of the conditions here at the left side so that we can help you identify the conic sections. So I'll be writing here the general form. So we have the complete general form so that you can be guided. Plus cy squared plus dx plus ey plus f is equal to 0. Now for number 1, we have x squared minus 4y plus 8 is equal to 0. So what type of conic section is this? A is equal to C. What is A here? A is 1, while C is 0. How do I know that? It's because A is x squared. So since there is no coefficient written here, we can only assume that the coefficient is 1. Now, can you see y squared? No, we cannot see y squared. So we can assume that C is equal to 0. So if C is equal to 0, then it means that this conic section is a parabola. Now, for the second equation, we have x squared plus 2x plus y squared minus 3 is equal to 0. So let us identify which is A and which is C. Now for our A is 1, which is this one. For our C, which is y squared, the coefficient is also 1. So if the condition is A is equal to C or A and C are both the same, then the type of conic section this is a circle. For this equation, we have 4x squared minus 8x plus 16y squared minus 12. Let's identify A. A is 4, while our C is 16. Now we can see that A and C are both here. They are not 0, so we cannot say that this is a parabola already. And A and C are of course not equal as well, so it is not a circle. Our only option is ellipse or hyperbola. So in checking the product of 4 and 16, we can definitely assume that it is greater than 0. So the only conic section applicable to this condition is an ellipse. And lastly, for this equation, we have 2x squared minus 8y squared minus 16y minus 16 is equal to 0. Now for our A is 2 and our C is negative 8. Please don't forget the negative. Most students forget about that. So A is equal to 2 and our C is equal to negative 8. So A and C is not equal, so definitely it is not a circle. Neither A or C is 0, so it's not a parabola. Now the only option is ellipse and hyperbola. Now, looking at the product of 2 and negative 8, its product is negative 16, which is definitely less than 0. So we can say that this conic section is a hyperbola. Now this ends our video and I hope that you learned a lot. Don't forget to like and subscribe to the channel so that you'll be updated, and see you soon in our next video. Thank you!